Hello back. In this video we're going to talk about some algebra around sets, and we're going to make sets which contains other sets. So a set of sets. Okay, have fun. Okay, depending on what order you're watching the videos, if you already looked at the logic videos, then you will have encountered this set of laws, and the same laws apply for sets. Or if you do this for the first time, then you only have to look at them once and then apply them for your propositional logic later on in your videos. Okay, so a first very simple law, and most of them are really common sense law. If we look at the first one here, so this is called the idempotent law, which just says if I unite A with A itself, so twice A, yeah, then of course we still have A. So that's quite common sense. But because it's math, we gave it a nice law, and then on your exam, if we ask you to simplify things, then we'd like you to mention that you're using this idempotent law in this kind of situation. Okay, if we look at the second one, associative law, then in fact you should compare it with something you learned in your first class when you were 8 or 9, when you said, okay, if we want to add 2 plus 3 plus 5, it doesn't really matter whether we first add 2 plus 3 and then later on 5, or whether we will do 3 plus 5 first and then later on add 2. In fact, when you were 8, you were already applying the associative law. And the associative law goes for the union operator as well as for the intersection operator. So if I look at 3 sets, I have a set A, I have a set B, and I have a set C. Then if I want to unite them, I don't care whether I'll first do A and B and then later on add C, or whether I will do B and C first, these two, and then later combine A. And so it's really independent of order. Associative law. Third law, commutative law, is also something you know all along. So again, if we go back to our 8th year, then if I would say 2 times 3, it's exactly the same as 3 times 2. And that applies for union, but also for intersection. And you can compare it again with multiplication or with adding. So 3 plus 4, exactly the same as 4 plus 3. Commutative law. The fourth law is a little bit more difficult, but again, if you take the parallel to your to your younger years, then you can again say, okay, let's say I have a question like 3 times 4 plus 2. Then we can calculate this in 2 ways. We can first do the addition, so we can say this is 3 times 6, which will give us 18, but we can also put the 3 inside the brackets. So I could also say 3 times 2 plus 4 is the same as 3 times 2 plus 3 times 4. And this thing you're now applying, that is called in an expensive word, the distribution law. And it applies to as well having a union first and an intersection between brackets, as an intersection first and a union between brackets. So distributive law applies both ways. Okay, then we have some straightforward laws like the identity law. If I unite a set with the empty set, it still stays the same set. And if I unite it with the universe, it becomes the universe. So if we unite with something, then it keeps having the biggest size And so A united with empty, A is the largest one, it stays A. A united with the universe, universe is the larger, so it becomes the universe. If we take the intersection, then the opposite applies. It goes to the smallest one. So A intersected with the universe will give us A because A is the smallest. And A intersected with empty set will become empty because that's the smallest. Okay, then we have the involution law, which just means if I take the complement of the complement, we get the original back. And of course, if we look at these complement laws, they don't need any more elaboration. You can work them out yourself. The only law I'd like to look a little bit closer to is De Morgan's law. And De Morgan's law goes two ways. So we can have a De Morgan law with a union in the middle or with an intersection in the middle. So let's first take the one with a union in the middle. So we have a set A and we have a set B. And then we would like to look at the union of the two. Okay, let's make that red. So A united with B is this red area. Then we want to take the complement. So then I have to draw the universe. So let's draw the universe. Okay. So A united with B complement. And then let's make it a nice yellow color. That would be this area. And so everything outside this A united with B. And that is the first part. A united with B, complement in the universe. So let's do it from the other side. So we have this universe. And let's just try to make a neat rectangle here. So we have the universe and we have a set A inside. And we have a set B. And then if we look at De Morgan's rule, so first we need to do the complement of A. So the complement of A means this part. Complement of A is this part. Everything outside the blue. Okay, if we look at B, then the complement of B, let's make it black. The complement of B would be everything outside B. But A is part of this complement. Well, and if we then intersect, I hope you see, despite my bad drawing capacity, that again, everywhere where we have a red and a black line, that's outside this A and B. So it's exactly the same. So A united with B complement is equivalent with A complement intersected with B complement. A similar thing applies for the intersection within the brackets, and what you only need to remember, if we have something inside bracket with a complement, this is equivalent with both sets outside of the bracket, and inside we complement the two sets and we collapse the sign, the operator. So an intersection becomes a union and a union becomes an intersection. So the C goes inside the several sets and we just switch the operator. So De Morgan is quite easy to remember. Two extra laws we'd like to show you are the absorption laws. And the first one we'll do is with the union first and then the intersection. So if we make a Venn diagram, you can easily see that this will indeed turn into A again. So if I have a set A and I have a set B, if I then first do A intersected with B, so that would give us this middle part, and then unite it with A, the first part, then we have as an extra this element, and indeed we go back to the original set A. That's called the absorption law, and it goes two ways. So we can also do it with the intersection first and then the union inside brackets. And I leave it up to you to draw the corresponding Venn diagram. It goes in a similar way as the previous one. Okay, on the exam you will get some questions like this exercise. So you have some strange formula. Don't try to interpret this. Some strange lecturer thought of this exercise and he said, okay, please simplify A united with B, intersected with B complement, united with A complement. And then you have to do it in the right order. And what we'd like you to do is do this with the help of the laws. So the first thing you see is that we have a complement here on the last part. So what we're going to do is the first law, and then we'll just mention it. So I'd like you to tell me what law you're applying. Would be De Morgan. So if we apply De Morgan to this one, then the first part stays the same. And then we intersect with, okay, B complement, complement, united with, intersected, because this operator changes, A complement. Okay, this is the first step. And then we have this BCC, and that was the involution law, and on the exam you may omit this one. And so BCC you can immediately write as B. Okay, then if we look at this exercise, we say union here, an intersection and an intersection. So that means that we can also write this as A united with B, intersected with B, intersected with AC, because the order is not important, whether I first do B intersected with AC or I'll first do this intersection, this first one. And what law are we applying now? That is the associative law. Okay, so if we look at this one, then now it's getting fun, because look at this first part. A united with B, intersected with B. And hopefully you recognize the absorption law. So if we have a set A, let's make a separate drawing. So we have A with B, united. And then we intersect it again with the last one. Then the absorption law tells us that it goes back to B. So the absorption law says now that this complete part can be changed into B intersected with A complement. And now we have an elementary form. You can't change it any further. So apparently this very complicated thing here is changed into B intersected with AC. Okay, this is ending of this video, and in the next video we'll continue with the second part of lesson 3 and we'll talk about sets of sets.